Thanks again to Team Origami. It's so great hearing from the winners of last year's case competition and seeing how participating has helped them land a job, gain confidence, and improve their teamwork skills. Well, all right, to get us started tonight, the first finalist team we will hear from is Team IT Crowd. Let's get introduced to their team members.
Australia stands at a crossroads between action and apathy, between taking charge of our responsibilities or shirking them, between short-term gain and long-term sustainability. Of agricultural exporting nations, Australia's emissions are highest in per capita terms, and a significant portion of these come from our agricultural industry. The question remains, what are we going to do about it? Good afternoon. My name is Nikki, and these are my teammates Matthew, Lux, and Mitchell. We are the IT Crowd, and this is our Seafeed Solution. Whilst the road to progress may seem a bit challenging, technology is a key driver of this change. And with carbon capture, utilization, and storage becoming a developed technology, the question is, what to do with the CO2? Whilst we aim to utilise carbon from every coal power station in Australia, our initial focus will be targeted towards Queensland. Queensland is not only one of the biggest energy consumers, but it's the state with the most amount of coal power stations, and it's the largest contributor to methane emissions. In the early stages of the project, CO2 will be collected from the Gladstone Power Station, as its seafront location and land-based facilities are desirable for our project. Globally, seaweeds are thought to sequester nearly 200 million tonnes of CO2 every year. The production of Asparagopsis seaweed farms in Queensland will not only utilise recaptured CO2, but will also act as the CO2 sink itself. Now, let's get into a little more depth. Using Asparagopsis farms, we plan to utilise CO2 in 3 ways. Our first utilisation will use CO2 from coal power plants in the production of land-based farms. Multiple Australian businesses have started using seaweed as a carbon sink as part of their products. What we aim to do is introduce to these established companies the possibility of using recaptured CO2 within land-based facilities. Land-based facilities require pumping air and water through the tanks to ensure carbon dioxide circulation. Our solution is, instead of running air, use recaptured CO2. This way, both existing CO2 and potential emissions are pulled from the atmosphere. Our second utilisation is through the production of ocean farms. Seaweed farms can collect CO2 up to 50 times faster than land-based forests. On average, a farm can produce over 19.4 tonnes of seaweed per hectare per annum, which results in 7.76 tonnes of CO2 being collected per hectare per annum. Currently, there is 25 hectares of ocean lease available, as well as 2 land-based facilities within Queensland. This alone will consume 149 tonnes of CO2 annually. According to the Australian Seaweed Institute, by increasing the growth of seaweed farming, emissions could be cut by 3% each year towards 2050 and can potentially cut emissions by 10% per annum beyond that. How amazing. But the wonders of Asparagopsis do not end here. It can continue to combat emissions through its life cycle, specifically its use. This is our third utilisation. Livestock is the third largest contributor to emissions, and in the next 20 years, it is expected that methane will have an effect 86 times more potent than carbon dioxide. But what if the use of Asparagopsis can change this? Multiple feed trials conducted in both the USA and Australia have shown up to a 99% reduction at a 2% inclusion rate in feed and have no impact on meat quality whatsoever. We estimate that a total of 181,000 hectares are needed to produce enough seaweed to supplement all cows' feed in Australia. Now, this may seem like a large number, but when put into context, this is only 0.44% of Australian marine area. Now, what goals does this hit? Our solution falls into 3 of the United Nations Sustainable Development Goals, with 4 of the specific targets being hit or worked towards. Target 8.5 is achieved as our solution creates a low barrier to entry within the job market. Target 14.3 is also achieved as seaweed reduces the effects of ocean acidification and the spread of dead zones. Targets 8.3 and 13.2 can also be achieved with our solution. If successful, our solution could be used as an example to persuade governments to integrate climate change measures into their national policies and provide financial incentives to small enterprises that are actively following those policies.
The most sustainable procurement methods will in most cases also be the most economically viable options for farmers, because in the crucial role of upcycling and second-hand products in the scalable supply chain for our solution. Almost all the resources needed for an offshore seaweed farm, like the ropes, anchors, floats, and farming columns, can all be fashioned from things commonly found in landfill and recycling. For cases where upcycling and second-hand use is not an option, we will create a comprehensive policy for responsible sourcing by deciding on the raw materials we want to incorporate based on their energy footprint, their recycling footprint, and whether they are locally or internationally sourced. Then we shortlist suppliers of said raw materials based on a 3-part process. First, we rank them according to their financial viability to ensure that our supply chain caters to its primary users, the aquaculture farmers. Secondly, we'll compare their environmental impact, and finally inquire about ethical practices. Once we have our shortlisted suppliers, we can categorize them based on location and geostrategic implications, and then distribute the supply load between them to ensure that we aren't introducing any vulnerabilities. Now, let's get into the details. In exploring the viability and feasibility of our solution, we based calculations of a model 5,000 barrel land-based farm. The margins on seaweed farming, as with all agriculture, will be tight. Assuming a sale price of slightly more than regular livestock feed and making allowances for electricity, labour and overheads, the net profit per kilogram of seaweed is only 9 cents. Fortunately, it's a very scalable operation. On the 5,000 barrel farm, over 1,000 tonnes of seaweed can be produced per year, and including depreciation estimates for materials and equipment, this leaves an estimated gross profit of $97,000. Startup costs to establish a seaweed farm are also low. Basic materials, equipment, and setup of the 5,000 barrel farm would cost no more than $100,000 to $200,000, which gives a rough payback period of a year or 2. Sea-based operations are even more cost-effective as they do not require the barrel and piping infrastructure. Additionally, startup costs can be subsidised by grants from the Australian government. Both the Department of Agriculture and the Department of Industry have grants available, ranging from $200,000 to over $1 million, depending on the size of the farm. We'll be rolling out our proposed solution in 5 phases, as shown here. Phase 1 is a research and development phase, with a small operation to gather data and validate the plans and assumptions made about the costs and operations of seaweed production. Phase 2 will be small-scale testing, which will aim to refine the assumptions made about marketability, scales, and price points. Phase 3 is local area deployment, where we anticipate a small number of businesses established in Queensland. This will provide more information as well as the business model's scalability and optimal size. Phase 3 will capture approximately 11,000 tonnes of carbon per year and reduce methane emissions by 22,500 tonnes. Phase 4 is full-scale national deployment, where we encourage and establish land-based and sea-based operations around the country. At this stage, with full national acceptance, we anticipate carbon capture of up to 1.4 million tonnes and methane reduction of up to 2.8 million tonnes. Phase 5 is future plans, crop diversification, international operations, different livestock opportunities. The sky's the limit. One reason for such a stepped and scaled approach is that our solution requires market acceptance. We will have to experiment with this and to test the market to find out whether net zero beef or carbon captured beef can sell at a premium, similar to free-range eggs. Scalability is key to our operation. For true environmental impact, it will require market acceptance and cost competitiveness. The potential limits to scalability will be market uptake, land availability, resource availability, and overall market size. Resource availability will not be the limiting factor here, as there are no rare or expensive materials used in the seaweed production or distribution. Land availability, especially sea-based locations, will also be critical. Current allocation of sea area nationally is 1,600 hectares, while approximately 180,000 hectares will be required to produce enough feed to mitigate the emissions from Australia's entire cattle industry. The biggest risk here is legislation not opening up more land for this use, as sea land use is relatively restricted, and seafeed would then be relegated to land-based operations only. Proportional market uptake at this stage is unknowable, and there is a significant risk to the project's future. Should the market uptake be low, yet the solution prove effective, legislative or regulatory incentives could be explored to encourage uptake of the solution. Overall market size would be the ideal limiting factor, as it would mean that the majority of Australia's beef cattle industry methane emissions will be removed and a substantial amount of carbon captured. The primary risks are based around misestimations around market uptake or misunderstandings of the seaweed production. Both of these will be mitigated by our careful staggered rollout process, such that we can refine our understanding of both the process and the market before the seafeed operation reaches significant scale. Also, there is a risk that regulation will not change to allow further sea-based seaweed businesses beyond the existing allocated land. If this is the case, land-based operations will be prioritised, with no significant effect on the overall strategy. We do not anticipate that any of these risks will derail the Seafeed solution, especially due to our careful and staggered deployment plan. Thank you.
As chair, I might just go first, and then hopefully we've got time to fit every judge with a question. You say that resource availability is unconstrained, but I'm just wondering about how you factor for the actual initial carbon capture out of the power plant, which isn't a costless exercise. And so for enhanced oil recovery, for example, that CO2 is selling for greater than $60 a tonne of CO2. Have you factored into your feasibility the cost of the CO2 that then feeds into your system?
Yes, there was a factor put in place for the CO2 that would feed into the system, especially for the land-based operations. That came out to, I think it was 3 cents a kilo. Just going to pull that up now. Yes, which comes at about $30 a tonne. That was based on what we could find for the estimations of capturing that. However, that is always open to the refinement, and that's what we're going to prove in the first 2 phases with the research and development, trying to refine those numbers and make sure that it's scalable and feasible.
I might go next. Thank you for your presentation. Just a question around the growth of Asparagopsis, say in Queensland. Is it a good spot to grow this particular variety, and the impact it might have on the local environment?
Asparagopsis is actually native to Australia, and it's the CSIRO and James Cook University that found this research. So Queensland is the perfect environment for it. And in terms of impact on the environment, it can only do good, especially with coal power stations in Queensland being next to the ocean. There's a lot of acidification. So having Asparagopsis grow there or near there will only do good, especially to the wildlife there as well, and the seaweed.
Sorry, Sophia, after you. I loved the presentation. I thought it was really interesting and incredibly well presented. It's no small feat to condense a lot of content and thinking into a really short presentation. So I really appreciate how hard you've worked on that. Must have taken many hours. One thing that stood out to me is that the methane abatement is so overwhelmingly more valuable than the carbon abatement. Did you factor in, when you looked at the sort of ACCU revenue stream, did you factor in the benefit of the downstream value chain that you were providing this product to, and thought about ways to capture that revenue? Or did you just think about the carbon abatement and the ACCUs attributable to that?
When we looked at the ACCU revenue, that was only for the carbon abatement. I couldn't find a good way to quantify the methane adjustments that we'd be promoting. And that was the primary benefit of our solution. So if there is a way for that to increase the revenues of it or make it more feasible, we would love to hear about that. But there wasn't anything that I could immediately find.
Well, I think to me, the good way to de-risk that is to instantly start lobbying for ACCUs from that value stream, because to me, it's just a slam dunk. It's a really great vehicle for emissions reduction. Thanks very much.
We did have a joke saying to get investment money to start lobbying. So that was considered an option.
So I have a couple of questions. I thought it was also an excellent presentation and well done. You should be very proud. I have a friend who is an Asparagopsis farmer, and I've also been involved with a couple of companies looking at this exact problem. So I guess my first question is around IP and whether you considered whether you would have to pay any license fees or anything for access to Asparagopsis, because it is one of the key technologies that the government is using to reduce emissions in the future. So, and I have a question after that, but I'll give you a moment to maybe answer it.
That's all good. Our goal was not to start the facility ourselves, but to help organisations already looking into this, like CH4 Global, Australia Seaweed Institute, and Seafeed, Seaforest. Yeah, our goal is to aid, to educate, and through those already established businesses, grow it even further to have an Australian market or even a global market.
Okay, and so forgive me, I couldn't find it exactly in your figures, but it was very quick. I understand that Asparagopsis is it's a very efficient and excellent additive. So therefore, the amount that you use in any feed is in the grams. So can you comment on the scalability of Asparagopsis to the amount of feed that would be used in beef and sheep in Australia?
So while it's only a very, very small proportion of the cattle feed, it still does scale up very nicely from a business point of view for the Asparagopsis producers, because there's just such a large beef industry in the country. The market is well beyond what is serviced at the moment, and we see that there'd be a very, very high barrier on that market in terms of full scale. Also, there'd be potential for international sale to other beef exporting countries such as Argentina. And I mean, sky's the limit beyond that.
Right. So I just suppose my comment, sorry, everyone, I'll be quick, but I suppose my comment to that would be that would limit the amount of the scalability of the amount of Asparagopsis in each feed would limit the amount of carbon that you can sequester, but it would be good for.
Yes, absolutely would limit the
I can give
carbon.
you an actual number for that. So we calculated that an average cow will need 0.1533 kilos of Asparagopsis for the entire year. And then with the 24.7 million head, that will require 181,000 hectares to grow enough Asparagopsis. And with that 1,801 hectares alone, that will capture 1.3 tons of carbon and will reduce methane by 2.7 million tons.
Okay.
Sorry, guys, we've hit the 5 minutes, and so we're going to have to move on to the next presentation. Thank you so much for a wonderful presentation. You guys have done an outstanding job.
Well done.
Great work.
Yeah, thanks for having us.